Hi, everybody. I'm excited to be here. I haven't been to anything like this in a really long time, so I'm super nervous. But my name's Lenny. I work at Apollo, ApolloGraphQL.com, the host of this, and a GraphQL company. And I'm learning a lot about AI and MCP, so I'm at the beginning of my journey, like probably some of you. I have some early work. You're some of the first people that I'm sharing this with outside of the company on managing everything that AI is going to be using that I'm excited to show, but I'm really here to get feedback. I want to know what you think about these ideas. So first off, has anybody here used Apollo Federation? That's exactly what I thought. Not a lot of people. That's fine. I know that Alex has used it because we use it together at Square/Block when we work together. So this is a really cool reunion that I'm having right now. But as a context setting, I'll do a super brief intro to what Federation is and then talk about what I'm building here. So GraphQL as an API technology invented by Facebook. They are famously a monolithic service, monolithic data store. And the design of GraphQL really reflects that, which meant that in companies that are structured for service-oriented architectures, Square had 3,000 services at that time. I'm sure it's grown by then. Since then, putting a monolithic API server just wasn't something that was going to happen. So when Apollo invented Federation, I was like, that's what we can do to get this API technology to be able to build really great front-end apps on. And the architecture looks something like this, obviously simplified, but GraphQL clients talk to an appliance we call the router, as Amanda mentioned. This is serves the GraphQL API, but its primary responsibility is to leverage GraphQL's declarative nature to automatically query plan against other services. So it's a distributed systems problem that we're trying to solve here. The other services in Federation we call subgraphs. They are regular old GraphQL services, but we're able to automatically combine them into a unified graph so that these clients don't know that it's actually talking to a whole bunch of distributed systems behind the scenes. And those services are probably owned by teams that work across, like that are distributed by the domain boundary. The ownership is really important here, and they own data sources, databases, and services behind them. So this is a collaboration model that leans into the different roles people play in distributed systems. Our consumers, GraphQL clients, have their job, but it's really driven by the producers, the people who know the domains they're working in, design the APIs, implement them on top of their data sources, and then they need to go through the gatekeepers of the system, the people that run the infra, because this router has to be a tier 0 service. It's serving all your traffic, so it better not go down. And then the architects who set the standards and best practices for your API design. And this works really well. We have a bunch of great big companies with billions of requests going through them every day, hundreds and hundreds of these teams. I mean, this is a really simplified diagram. And that's been cool, but of course, enter AI, everything's changing, and maybe the most positive spin is it means that we can start rethinking everything. And a few ideas have been coming up a lot for me in my conversations in regards to the future of API management in these platforms. And the first one is that instead of producers driving things, it's becoming the consumers driving things. The AI agents and the people building them are driving the conversations, and waiting for those producers to design their APIs and implement them and go through the gatekeepers is too slow, and also the use cases are more varied and dynamic and adaptable. So it's flipping the conversation. Yet, none of the data sources that you want to build on are designed for LLMs. They don't have great documentation, if they have any at all, to teach the LLM how to use them. They do too little or too much, wasting tokens. And so we end up having to put adapters around these systems, APIs on APIs on APIs. That's what MCP is, and it's a great example of it, but it's something that we've done a lot. We build APIs on APIs on APIs on APIs. The whole system is that. And I think it's kind of funny how much of our job is that. And there is also a dependency graph kind of hidden in all this, that these SDKs depend on this, which depends on those, which depend on those. And when I'm thinking about building things on other things, what I reach for in my day-to-day are package managers. I'm building a JavaScript application. I'm going to use NPM. What I'm going to show, I build in Rust, which Cargo is a great package manager. And I actually, I'm using third-party packages for a lot of stuff, including the Rust SDK. Thank you, Alex, for MCP. But I'm also structuring it in a workspace as different packages because it's easier for me to kind of wrap my head around what each thing is doing. But it's a lot better for Cloud Code to understand the structure of the application and where it should be doing things too. So the question I have is, should we have a package manager for APIs? And I'm going to jump into a demo, and fingers crossed this all works. But I have a command line tool. Is that big enough? I have a command line tool I very creatively called API Package Manager, APM. And it has a lot of the subcommands you might expect working if you've done any of this stuff, which you most likely have. And in this demo, I am going to initialize a project. And of course, I'm going to make an MCP server using Apollo MCP Server because that's why we're here. And I'm going to do a little demo magic too. And then I want to get into the design of this a little bit, about the choices that I'm exploring and I want your feedback on. So this MCP server project is going to serve an API, but it's also going to sit on other APIs. And in this package, I'm going to give it a name and a version like you would with a JavaScript package. But maybe the thing that is unique to this is that there's a type. This has got to be a polyglot system because there's so many kinds of APIs and data sources and consumers of APIs and layers in between. So that's kind of an interesting part that I'm still working on. This particular package has to have some runtime information. I'm going to use Apollo MCP Server, which is a specific type of MCP server that actually just delegates the tool implementation to GraphQL. I'll show how that works in a second. And then, like a package manager usually, like packages often have, it has dependencies. So this MCP server can't do anything on its own. It's going to have to depend on other things. And I want to materialize that in code in a declarative way. And another choice that I'm playing with here that I really like, I kind of stole this from Dino, is that a file can just be a package. So I've structured this kind of boilerplate MCP server to have actually 3 packages all at once. If I do my little tree command here, the MCP server depends on a set of operations, GraphQL operations. Those become the tools. Those operations have to call an API, so they have to depend on API. And this would be the API hosted by that router in the middle. So it also doesn't have anything. It can't do anything by itself. But I can add dependencies to this thing, to things. So I can add to that underlying API dependency on an open API specification, just the standard pet store one. And with that, I should be able to APM dev, fingers crossed. So it's going to build all the packages in dependency order and start the software, including the MCP inspector. And let's see, it's too big. I'll connect, list my tools. All right, so I just have like an example tool in the boilerplate. This doesn't do anything interesting, but it does show that it works. So that's kind of like, I'm going very fast, but that's a very brief look at packages on packages and being able to have a APM, some command line tool that lets you manage this stuff. But I think where things get really fun is I'm going to run Cloud Code. And in that boilerplate, I went ahead and added the JSON file that says, here's some MCP servers I should use in this project. And I'm going to use that APM command line tool as an MCP server. And I can say, make an MCP tool that lists pets. And I think this is this is taking that benefit of breaking things into packages and extending it to making it useful for LLMs and agents to use as well. So the tools available are specific to this kind of package and its dependencies. There's a lot of code that's not actually represented on disk, or not in a way that maybe would be easy for an LLM to understand, but the package manager understands the dependencies and can surface things. So it's going to see what's in the package. It's going to search the schema in that dependency for anything related to what I asked for. It's going to figure out what else is there. And then it is going to actually write the code for me. So like I said, this particular implementation of the MCP server uses GraphQL operations as tools. And then once it wrote it, it's going to verify that it worked by running apm build and apm test. And it would redo it if it got anything wrong. So I have the devs was still running, so hot reloading should have worked. There's my new tool. And it listed a bunch of pets, which some really bad boilerplate names. So that worked. I'm very happy about my demo. So that's kind of the broad strokes of a very MCP-focused demo of this. But obviously, I want to be able to do a lot more, taking all the things we've learned, building those really big federated graphs against distributed systems, and then wrapping that up in ways that make them easier to use for you and your agents. So obviously, I want to make support more types of APIs through different packages. It's a little wonky, so I wasn't going to demo it, but I've even taken another MCP server and used it as a data source, and then written other MCP tools on top of it, including the ability to call 2 tools at once. That was pretty cool. And the ability to apply transformations and annotations to those dependencies. I didn't touch on this too much, but that Open API spec for the pet store, I actually namespaced that, transformed it on its way into the graph so that I could pull in multiple APIs into the same thing without worrying about conflicts. And being able to also add semantics, documentation to teach the LM more about what these APIs do, build tools easier is an important part there too. And be able to apply policy like authentication and authorization about what parts of the APIs need what kind of scopes and claims on your JWT. And not exactly part of the packages and the package manager, but then being able to take a package and its dependencies, which some of it actually might just be a description of an external service, and make sure you can deploy those in your different environments and promote them across dev, staging, production. I think there's a nice story there with lock files, like package.json and package lock.json that I'm still working on. So if you have ideas there, love to hear them. So just to kind of sum up, I think an API package is really a description of something that has a type so we can support a polyglot system. And it describes the API itself, its schema, or however you want to describe it. Describes its dependencies, very importantly. But more subtly, it has to also describe what it can provide if it is a dependency. If something depends on this package, what can it get out of it? That's part of the polyglot idea. It would probably have to describe some of its runtime, and then in some cases, it can actually describe its implementation. A lot of what I actually showed under the hood is using my last project, because it's called Apollo Connectors, which is a way of implementing an API actually declaratively in a GraphQL schema. And then the package manager underneath that, would be a one tool with a unified interface that makes it really easy for people and agents to work on any kind of project, focus on that one package, but with all the same commands and workflows. And I do think this probably means that it's a plugin system, probably a dynamic plugin system, because there's a million kinds of APIs and a million ways to work with APIs, so probably want to have an open system for that. Its core responsibility would be to build the dependency graph and then provide all the commands you would need for the entire software development lifecycle. The last thought I had, kind of playing with this idea, have you heard that Docker allows you to treat your servers as cattle, not pets? I've heard that many times, but I'm not sure where I heard it from. I'm not sure if it's popular. A lot of people at Apollo reacted very negatively to this framing. So ChatGPT says forests instead of bonsai trees. I think there is something here. With Docker, you can wrap your software up in this standardized container and then just throw it at a declarative system like Kubernetes, and it just runs. You don't have to name your servers anymore, is kind of the metaphor. And I think that there's something maybe here where we can just have all our APIs we can just plant them all in the forest and let them do their thing. Because what we actually want to treat as our pets or our bonsai trees are the AI agents and the front-end applications themselves. That's where we want to spend our time and really craft the user experience and get that right. That's what's I think is going to be the hardest part. So I want to make the API stuff as easy as possible. So I don't know. Tell me your thoughts on either of those two metaphors. But that's what I've got today. So thank you so much for your